Survey of Algebra 2-1, Graphing Linear Equations. So for beginning graphing linear equations, we're going to go ahead and complete a table, and then we're going to graph. And we say linear because we're looking at a line here. So we're going to be graphing lines today. So in this first one, it says y equals 1/2 of whatever x is, and then they're giving me a bunch of x values. So the way I'm going to do this is I'm going to look at all these x values, -2, then 0, then 2, then 4, then 6, and I'm going to be substituting for x. So we're going to substitute for x, and then we're going to solve for y. So my first one would be like y equals 1/2 of -2, because -2 is the first x value in my table, and half of -2 is a -1. And then I would do y equals 1/2 of 0, which is just going to be 0. And then I'm going to do y equals 1/2 of 2. And half of 2 is just 1. So now what I notice is that my x values have a pattern in my table. I got to fill in that one still. My x values are -2, 0, 2, 4, 6. So my x values are going up by 2 every single time. And since there's a pattern for my x values, there's also going to be a pattern for my y values. So my x's are up by 2. So I always like to do 3 math problems, and we did do 3 math problems. We subbed in -2, 0, and 2. And then I like to look for a pattern. And since I have a pattern in my x's, I should also have a pattern in my y's. And I can see that the y's are going up by 1. And so that tells me that the next value will be 2 and then 3. And it still works. Half of 4 is 2, half of 6 is 3. So we have this cool pattern where my y's are going up by 1 and my x's are going up by 2. So now I'm going to go ahead and graph. I'm going to plot all of these points. So it says when x is -2, y is -1. I have 0, 0. When x is 2, y is 1. When x is 4, y is 2. When x is 6, y is 3. And then I'm going to go ahead and connect them. And when I'm graphing an equation like a y equals x, there's no weird square roots, there's no powers. I should just get a line every single time. So now I'm going to do all these extra things that it's asking me to do, and I'm going to switch colors for this. So it is saying to label the y-intercept. So it's where the graph crosses the y-axis. So my y-axis is this vertical axis, and my graph is crossing it, and it's crossing it right here. And so my y-intercept is 0, 0. And I notice that I also have a 0, 0 in the table. Makes sense. And then I want to show the difference in x and y values in the table and on the graph. So in the table, I kind of already did that. I was looking at patterns. So I said my x's go up by 2, my y's go up by 1. But let's check that on my graph as well. So from one point to the next, I'm going up 1, and I'm going 2 to the right. I'm going up 1 and 2 to the right. So I'm showing that 1/2 over here. So what I want you to see is that I have an up 1 over 2 pattern in my table. I have it in my graph. And then I have this 1/2 right here. So it's just kind of cool to see all those similarities. And I could even write at the end of this, I could even write a +0. So I have the green stuff kind of going on with my slope. And let's maybe just highlight that again, how I've got a +1 across for my x's or for my y's. I have a +2 for my x's. And so I have the up 1 over 2 on my graph, and I have the 1/2 right here. And then in red, I have my y-intercept is 0, 0. I have a 0, 0 on the table, and I have a +0 in the equation. So we're trying to draw connections between all of those things right now. So let's go ahead and look at our next math problem. So the next one is 3x plus 2. So a little bit more complicated this time, but I've got another set of x values that have a pattern again. I'm going to go ahead and plug those in. So because my first value is -1, I'm going to substitute -1 for x. 3 times -1 plus 2 is -3 plus 2 is -1. And then I'm going to do 0. Y equals 3 times 0 plus 2 is 0 plus 2 is just 2. So my first, when I plugged in -1, and that was this -1 right here, I got out 1. Then I plugged in 0 because x said x was 0 and my y was 2. And then I want to do one more. Y equals 3 times my next value that they give me is this 1 right here. So 3 times 1 plus 2 is 3 plus 2 is 5. So now I'm going to look for a pattern. My x's are going up by 1s. It looks like my y's are going up by, oh, this first one was a -1. I didn't have a pattern there for a minute, did I? -3 plus 2 should be a -1. So my y's are going up by 3. So this is going to be an 8, and this is going to be an 11. So now I'm going to go ahead and graph these ordered pairs. So I'm just doing a quick graph. And 2 is 8, and 3 is a little bit off my graph. It's 11. I'm going to connect with a straight line to the best of my abilities. And then I'm going through and I'm identifying all these parts again. So I want to label my y-intercept. So if I'm looking at my y-axis, my graph crosses. So by graph, I mean this blue line that I drew crosses my y-axis right here. So this is my y-intercept. My y-intercept is 0, 2. I have a 0, 2 in my table, and I have a +2 in my equation. So now I'm going to look at my graph and my x's and y's, my differences. That means what I'm going up by in the table and in the graph. So my y's are going up by 3 every single time once I fix that first one. And my x's are going up by 1 every single time. And let's look at my graph here. It looks like up 3, 1 to the right. So +3, +1. I have up 3 over 1, up 3 over 1, up 3 over 1. And you'll notice that my slope is really just 3 over 1. So that number multiplied by my x. So we're just looking for patterns right now. All right, I'm going to go ahead and go on to problem 3. It looks like we've got 2 more. So on this one, let's see, it says y equals x plus 5. So I'm taking all of these numbers, -1, 0, 1, 2, 3, and I'm substituting them in for the x, and then I'm just adding 5. So first I'm going to start with the -1. So y equals -1 plus 5. So y equals 4. And then I'm going to plug in 0. Y equals 0 plus 5. They're all going in here for this x, which is going to be 5. And then y equals 1 plus 5. So y equals 6. And then we have 7 and then 8. So let's get this stuff out of the way. So now I'm going to go ahead and graph. So -1 is up 1, 2, 3, 4. 0 is 5, 6, 7, and 8. Draw my line. I want to label my y-intercept again. So if my y-axis is right here, my line is right here, this is where they're crossing. So I'm looking for where those two lines cross. So I have, again, a 0, 5 here. I have my y-intercept at 0, 5. And I have a +5 in my equation. And now we're going to look at my pattern for y's and x's. My y's are going up by 1. My x's are also going up by 1. I have a 1x right here. And my graph goes up 1 over 1, up 1 over 1. So it's +1 for y, +1 for x on my graph as well. And that's what that looks like. All right, so we are on our last math problem. Y equals -2. This is kind of a weird one because there's no x in here. And so when I go to substitute an x value and I can't, it just says, well, y equals -2. So I'm going to fill in -2 all the way through here. And then I'm going to graph -1 down 2, 0 down 2, 1, -2, -2, -2. So I end up with this horizontal line. So my y-intercept, let's see, still where I cross that y-axis. So this -2 right here. My y-intercept is the point 0, -2. And of course, there's a -2 here. There's a 0, -2 here. And then what in the heck is going on with my change in my y values this time? So if I look at all these y's, there's no change at all. Even if my x's are going up by 1, so there's no change in my y's. And if I look at from one point to the next, all I'm doing is going right. So there's no change in my y, there's only a change in that x direction. So that is it for our notes, just kind of beginning working with tables and starting to maybe draw some connections between equations and tables and graphs.